This video is to help you understand what to expect in the measurement and density laboratory experiment. This week, you will continue to practice recording measurements using the correct number of significant figures. You should apply what you learned last week about reading between the lines on the minor scale of a graduated measuring tool in order to record all of your data with the appropriate number of decimal places. You'll also need to recall some important material covered earlier in the semester about significant figures and temperature conversions. In addition to reviewing this material, please read ahead in your textbook to learn a little about solubility. You'll need to know what is meant by the term like dissolves like. In part A of this lab, you will simply record the temperature in the room using a thermometer. Make sure you read between the lines and record the appropriate number of significant figures. Then, you'll practice using the rules of significant figures correctly while doing temperature conversions from Celsius to Fahrenheit and Kelvin. In part B, you'll practice measuring with a ruler and the electronic balance in order to find the density of two metal bars. The goal in this part of the lab is to practice measuring and performing calculations using the rules for significant figures, but your goal is also to identify the type of metal in each of your bars. You will do this experiment using a cylindrical bar and a rectangular bar made of different metals. Measure the dimensions of each bar and use simple math to calculate the volume of each bar. You will use the volume as well as each bar's mass in order to determine its density. Make sure you show all of your calculations and that you use the rules for significant figures correctly when recording your data and when doing your calculations. You will be able to use the density of each bar and its color as clues for identifying the metal composition of each bar. In part C, first, you'll determine the density of 4 liquids. Then, you'll put the liquids in order from most dense to least dense into a cylinder to make a density column. To measure the densities of each liquid, first, you'll need to record the mass of your empty 10 milliliter graduated cylinder. Then, you'll need to measure a volume of one of the liquids and its mass. To do this, pour approximately 10 milliliters of one of the liquids into your 10 milliliter graduated cylinder, the one that you just massed. Make sure you record the volume as precisely as possible. Then, take the mass of the cylinder with the liquid inside, and from this you can calculate the mass of just the liquid. From the mass and volume you measure, you will be able to calculate density. After you do this for one liquid, pour that liquid into a clean beaker and set it to the side. Make sure your beakers are labeled so that you don't mix up your liquids. And make sure you clean the graduated cylinder well with soap and water between measuring each liquid. Some of these liquids are particularly difficult to clean and to pour, so please be patient when pouring viscous liquids and make sure you clean your glassware well. After you determine the density of each of the 4 liquids, you should order them from most dense to least dense. At this point, you can add just a small drop of food coloring to your heaviest liquid and the third heaviest liquid if you want to make the next part more fun. Then, start with the most dense liquid and pour it gently into a 100 milliliter graduated cylinder. Carefully layer the other liquids by pouring slowly down the side of the graduated cylinder. You should start with the most dense and end with the least dense liquid. If you do this carefully and in the correct order, you will end up with 4 layers. At this point, step back and appreciate your art. Record your observations and draw a sketch of your column in your notebook. Label the identity of each layer. Consider how density is related to the order of these layers and their ability to lay on top of one another. Now let's see which layers will be soluble in one another. You may be able to predict which layers will mix based on their polarity. To stir up the layers, pour back and forth from the cylinder to a 100 milliliter beaker. Record your observations and sketch what happens. Try to predict which layers have mixed and why. After you've finished these 3 parts of the experiment, please clean your glassware well and wipe down the bench so that it is ready for the next group of students. Then, please return to the classroom to work on your post-lab questions.